In this video, we're going to be discussing aperture. Aperture is a very easy concept to grasp, but the numbers and the math are very difficult to grasp. And so I would suggest that if you need to pause this video and look at a screen for a while and think about it, and then continue on, or if you need to watch this video more than once, whatever you need to do. I know it took me a long time to grasp some of these things, and so I want you to take that time too, because it's important to get the basic understanding down. So what is aperture? Aperture is the size of the hole in your lens which lets light in. Now I call it a hole a lot. You'll see some tutorials call it an iris because they relate it to your eye and how the iris in your eye gets bigger and smaller. If bright light comes to your eye, your iris is going to get smaller so that your brain doesn't hurt. And if it's really dark outside, your iris is going to get bigger to try to let in as much light so that you can see. This is the same with the camera lens. That is a very easy concept to understand, but it gets much more difficult. An aperture is measured in f-stops. Befuddle me. Couldn't think of a topic for this slide. F-stops are confusing because of the opposite language involved, and I am very befuddled most of the time because, well, you're going to see. A maximum f-stop. A maximum f-stop is the highest setting your camera will allow to let in the most light. So maximum and highest and most, those are all big. However, this setting is actually the lowest number. So the lower the number, the highest setting. The lower the number, the most light gets let in. The lower the number is your maximum f-stop. And the maximum setting example would be maybe an f3. Some cameras have f1. Mine doesn't go down. Mine goes down to a f3.5. So you will have to be finding later on in this tutorial your maximum f-stop for your camera. Now the minimum f-stop. The minimum f-stop is the opposite. That's where I said this is easy concept, very difficult to get into your head. The minimum f-stop is your lowest setting, which allows a minimal amount of light. So it's your lowest setting, minimal light, minimum f-stop, all little. However, this setting is actually your highest number. It's just the opposite. Why they do that, I don't know. Well, we'll see why they do it, but still, they could make life easier. A minimum setting example would be an f32. Aperture range. What is the aperture range of your camera? An aperture range is from maximum to minimum. So you should find on your camera the maximum, which is the smallest number, to the minimum, which is the highest number. You see how this is confusing? That your camera could go. I know while I'm out there trying to learn this concept myself, and you see all these aperture ranges listed on bars. They're kind of I think they call them an aperture scale, and I was trying to to get that concept in my head, and lo and behold, those numbers aren't even on my camera. So it wasn't helping me at all to look at those things and translate that to my own camera. So that is going to be the main purpose of this lesson. Know your camera's aperture range. Get out your manual and search online. Play in aperture priority mode if you have one, and get out a pen and paper and start writing them down. This lesson, that's going to be your assignment, and I'm going to show you that at the end of this video a little bit more. But your manual is going to maybe tell you. I actually just Googled specs for my camera online, and that gave me the figures for the maximum and the minimum. But then I had to play in aperture priority mode and get out I actually had my computer in front of me, so I made notes on the laptop, wherever you want to make notes, and get every aperture in between your maximum and your minimum. The maximum can also be found on the camera lenses. So here's my camera lens, and the aperture is the set of numbers that says 1/3.5 to 5.6. So the 3.5 aperture is for the 28 millimeter focal length. You'll see over to the left it says my lens goes from 28 to 135. Your aperture is actually based on your focal length of your lens. So every single lens is going to be a little bit different on their aperture range. So my maximum aperture is listed on the lens, not my minimum, so I could easily find my maximum. The 3.5 is the maximum, or the biggest hole for my lens when it is set at 28 millimeters. The 5.6 aperture is the largest the hole will go when my camera lens is set at 135 millimeter focal length. We're going to talk about focal lengths here in just a little bit, and so that's why you have to grasp all these concepts and go back and watch this video again. It's really difficult to teach this because there's so many concepts to grasp, but just know that you can find it on your lens and that the first number is for one focal length and the second number is for the other focal length, and we're going to look at that more here in this tutorial. Exposure and aperture. Basic concept: if the hole is too big, which is your low number, this is where it gets confusing. That's where our cheat sheet's going to help, because you can just whip out your cheat sheet and easily see what those numbers are for your particular camera. And if you'll see that when the hole is too big for the relationship of the shutter speed and ISO, then your photo will be overexposed, just like the iris of your eye. You go, pain, I'm looking into the sun, and as your iris is trying to get smaller and smaller to let in less light, because you've been overexposed to the sun. If the hole is too small, which is a high number for the relationship of the shutter speed and ISO, remember this is that tug of war that we talked about in the other tutorial, then your photo will be underexposed. And so you're out in a dark night and you're underexposed, you can't see, and your iris has got to open up and get to a bigger hole, and so that it can be exposed correctly, because you're not seeing enough. Here's a relationship example. Okay, I have these two lines. The top line is your f-stop line, your aperture. The bottom line is your shutter speed. We will be talking about shutter speed numbers in a separate tutorial. It's too much to grasp for right now. So just know that on the bottom line, the numbers to the left are faster. The shutter speed goes open and close real fast. Boom, boom. And the shutter speed gets slower going to the right. And so, whoop, whoop, takes longer to open and close. On the top, the numbers on the left, as we talked about, the smaller numbers have the bigger hole, lets in more light. On the right, did I just say that backwards? On the left has the bigger hole, smaller numbers, lets in more light. On the right, it has the smaller hole but a bigger number and lets in less light. And so the shutter speed on the bottom, if it's faster, is going to let in less light. And if it's slower, it's going to let in more light. And so you can see that they are opposite. Over here we have bigger hole, lets in more light. Over here we have slower, lets in more light. They're opposite across from each other. And here lets in less light, and here lets in less light, opposite of each other. And so if your camera, and these are just numbers, these are some numbers from my actual camera, together in a row. This doesn't mean that they're the perfect example, and that they correlate, but this is just the concept that you need to get into your understanding. The 5.6, let's say your camera meters, and it says it needs an f-stop at 5.6 and an shutter speed of 40. Then you can actually use any number of these combinations. If you want, you can use a 5.0 with a 50, or an 11 with an 8. This is just an example. So because they do correlate and go up and down, because as you let in, remember I said that they're opposite of each other, so you're just going to have to sit here and think on this a little bit. Let me show you here. If we move this over, and now the 5.6 is metering at a 50, then the 6.3 is at a 40. So it has moved opposite of each other. You have to think across the board. If you let me think on how to say this. The f.6, we made the, I had this all figured out before the video. We made the shutter speed faster, and so we'd have to lower the let me show you on the next one. This one here is really pretty good. This is a site I recommend that's going to help you understand it a little bit better, and we're going to take a peek at it, and I recommend going to it. It's kind of fun to play with. It has these default settings right here with your, we're not even going to play with film speed right now, but you can, but we're just focusing on these two. This is an f-stop of 5.6 and a shutter speed of 1.25. It's what your camera has metered as a good exposure. But let's say that I want to change the aperture. Maybe it's a little, my photo's a little bit dark and I want to make my hole a little bit bigger. So a bigger hole, if you go back to this one, the bigger hole is the lower the numbers. So if I want a bigger hole, I'm going to go down to F4. But now you can see that it is overexposed. It's letting in too much light, and so it's overexposed. So to fix that, I have to change my shutter speed to something that is faster. Let's see which way we had to go. Faster was the bigger numbers going up, so that would be this way. And now you can see our exposure is correct. So when I went up here, I had to go down here. Let's say I went up one. Now we're underexposed, and so I needed to go the other direction on my shutter speed. So you can see that they're opposites in order to make good exposure. When you move one way, you're going to have to move the other way to get it to be good exposure. So sit here and play with this a while. I recommend it. It's a great site. And why call it a stop? The term stop is from early photography. Early cameras used wooden panels with drilled holes in them, and each panel had a different size hole to stop the light from entering the camera. So the panels were inserted to stop the light. So you're going to hear often the term stop down. And when you're reading tutorials or watching videos online trying to learn more, you're going to hear the term that you will stop down your aperture. And that has to do with closing the hole. But why F? Warning, math ahead, math ahead. I'm going to make this as simple as possible because I really don't think you need to understand all of the math in order to do this. The relationship is more what you need to understand. But think of F as fraction, F for fraction. And I don't want to insult you with your math skills, but you know, I'm bad at math, so I make these videos for the people that are like me. 1/4 of a pie is a fraction of a pie. Yum! So a fraction is 1 divided by 4 for 1/4 of a pie. You may remember this, bringing it back from your elementary school days. An f-stop is the focal length divided by the diameter. So just like 1/4 of a pie is 1 divided by 4, we have so your f-stop is a fraction of your focal length divided by the diameter of the lens opening, or the iris. You can think of lens opening as the iris of the camera. The diameter, if you remember difference between diameter and circumference, diameter is the distance across the circle through the center. So if you would put a ruler on your lens and measure how the diameter of the iris, you would measure just straight across. So here's the formula. If you have an f-stop equals focal length divided by lens opening. And that, if you look here, divided by just like 1/4, and that slash means divided by. So that's the basic math. But you say, whoa, what is focal length? I know what a lens is. I know what the lens opening is. But what is focal length? The focal length is the distance between the surface of a lens, I think it's the center or the surface of the lens, to the focal point. Whoa, what's a focal point? A focal point is the is between the lens and the camera sensor. The focal point of a lens is that spot where the lens will focus rays of light. And so that's just a concept you have to understand, not something we really need to know in order to take photos. So you've probably seen graphs like this before, where you have your lens here and your focal point out here, and your camera sensor is going to be on this side. So between your lens and your camera sensor somewhere is the focal point. And so the distance between the lens and the focal point is your focal length. So it's a measurement in the inside of your lens. And your focal point, your focal length can change when you're zooming in and out. It's also called a focal distance. They're the same thing. So zoom, when I am turning that knob on my DSLR and I am zooming with my DSLR, my focal length is changing because my lens is moving out, and so that's going to change the focal point and the distance from the lens to the focal point. And the same thing is in your point and shoot camera. It's all happening inside your camera, your focal length is. And basically it's helped me to just think of focal length as zoom, my zoom setting. Focal length on your camera can be found here on your DSLR, right on the side. So my focal length inside my camera goes from 28 millimeters to 135 millimeters. When I'm at 28, I am zoomed in. When I am at 135, I am zoomed out. And there it is again. You can also see it right there on the camera lens. You're going to see it in that number of millimeters. And here's my point and shoot. You can see when I went and used it underwater, it got all banged up on my trip on the reefs underwater. But as this is an underwater camera, but you can see here it also lists right on the front 5.0 to 2.5 focal length. So this one is not very wide of a big change between the two numbers, distance between the two numbers. And you can see also right here, you can see my f-stops are on here. So this camera actually gives it to me also right on the camera. So back to the math now that we know a little bit more. Focal length, this is our equation, divided by f-stop equals the lens opening. So we have a focal length, I made this easy math, of 200 millimeters. So let's say we have a really high zoom lens and it's zoomed in at 200 millimeters and the f-stop is f4. So focal length divided by 4 is 55 millimeters wide. So the iris in my lens is going to be 50 millimeters across. That's basically it. And another example, a 50 millimeter lens is a common lens type for DSLRs. And if you have it set at a f-stop of 2, 50 millimeters divided by 2 is 25 millimeters. So your iris is going to be 25 millimeters across. And that's the basic concept. And you won't ever need to know that again. But what you do need to know is your particular settings for your camera, your f-stops. And I'm going to give you the tools to create your own cheat sheet, and you can see on the left side you have your maximum aperture with the biggest hole, and on the right side the smallest hole. So this little graph lets you know that the numbers on this side have bigger holes than the numbers on this side. And because I had so many f-stops in my camera, I had to have 2 rows. And so this 10 actually continues over here with 11. And so more light enters here, makes a brighter image over here because more light is entering. You have a shallow depth of field, which is something we're going to learn in the next lesson, and a blurred background. And the larger numbers over here are your minimum aperture. You have less light entering, makes the image darker because your iris is getting smaller. You have a deep depth of field, and everything is sharp, which these 2 bottom things we're going to learn in the next lesson. So you need to make a cheat sheet for your camera, because I know when I'm looking at all the figures, it just is so much easier for me to see it in black and white when I'm trying to determine what I'm doing. And I put my lens focal length down here. So my focal length is 28 to 135. My maximum aperture is 3.5 to 5.6. So for a 28 zoomed in, it's 3.5. For a 135, it's a 5.6 for maximum. The minimum aperture is 22 to 36. So basically I need to look at these 2 set of numbers together. So when my camera lens is all the way zoomed in, it goes from 35 to 22. So if we go back here and look at it, it goes from this 3.5 all the way to this 22. When my camera lens is pulled in, zoomed in, I cannot get these 4 apertures. But if you look at this set of numbers, when I zoom in on something, 5.6 to 3.0, I can go from 5.6 to 36. I think I said that wrong on the last screen. So these 4 numbers I cannot get when I'm zoomed in. And so to understand that concept and play with your camera and know your numbers is important. And you can figure it out with your point and shoot. I actually had to, I found the range online on some specs that I looked up. This was from the front of my camera, and obviously because this distance is lesser, my aperture range is going to be lesser. And I played with my camera. I just was zooming it in and out and pointing and reading the different settings, and whoops. And these are the ones that I found. I did get it to jump up to 11 once, and I didn't know if that was a fluke or not, but I'm going to continue as I take my photos and I look at the specs of them on in my folders, as you learn how to look at the f-stops after you download to your computer from either a program or your folders. I'm going to continue to observe them, and I might be tweaking this because I might find others in there, but you can do it for your point and shoot to help you understand too. So this is your lesson. Take the download and play with your camera and make a cheat sheet for your camera.